to protect ourselves from known risks. Most of the time, the sun shines and people go about their lives carefree. However, clouds can form quickly. We have developed tools to overcome obstacles quickly, effectively, and safely. Most of you have probably heard of it. It's called an airplane. An airplane has a fuselage. The fuselage is where you take your seat and your luggage is stowed. There are also windows so you can see mountains, or, depending on your profession, watch obstacles such as financial pressure, growth targets, increased automation, competition, or staff shortages fade away. To be able to fly, you need wings and a tail, but these alone will not get you in the air. Nothing works without large and reliable engines. The design and functionality of the individual components of an aircraft are a metaphor for your organization and its employees. And eventually, someone has to decide where the journey goes. The wings help carry the weight of the aircraft. They must be proportional to the aircraft. If they are too big or too small, the plane won't fly high or fast enough. The wings of your organization are the selection, education, and training of your employees. But the wings alone will not get the plane off the ground. Engines are vital to provide the aircraft with sufficient thrust to move forward. The motivation of employees is the engine that gives your organization the necessary thrust to move ahead. An engine is extremely reliable as long as it's taken care of. And even if there are issues with one engine, there is at least a second one to generate sufficient thrust to keep the plane in the air. In the tanks, there is fuel. There has to be a sufficient amount. It must continuously flow and be of good quality. If the fuel is contaminated, it can clog the pipes. The fuel that runs through every company is communication. Like fuel, communication can freeze, explode, run out, or be unevenly distributed. Fact is, nothing runs without fuel. The rudder is controlled from the flight deck, as is the elevator, which is responsible for making the plane ascend or descend. Together, they are responsible for a smooth and coordinated flight. They control how high you fly, how to fly with the least resistance, and how to compensate for any disturbances. Lack of control or poor coordination can lead to a turbulent flight even without external factors. Turbulent flights are extremely uncomfortable for all of us. It's also important to know of any external threats or obstacles that may lie ahead. For this purpose, the aircraft is equipped with radar, which must be switched on, of course, and whose signals must be detected and interpreted. Good pilots keep their eye on the radar and think far enough ahead to identify hazards in time to avoid them.
It's time to start. We should start today's class, okay? Today's part is a new series of this class, Human-Robot Engineering, Human-Robot Interaction. And today's series looks like this, yes. 3-week series, the robot dependability and human error, and safety of systems, and affinity, friendliness. It's the 3 weeks we will discuss about these things. And especially today is two parts, dependability and the error, human error. Dependability, system dependability or reliability, but formally the word dependability has been used. So therefore, how to consider about this dependability, reliability, or the opposite word is a failure. So therefore, the failure detection and failure analysis is very important. And in many cases, in some accident, we should consider this is some equipment failure or the human error we have to distinguish. So therefore, the human error is also that we have to consider. So therefore, we have two topics today. Yes, dependability is the definition and something, and the how to find and how to analyze the failure is FTA is one of them. So therefore, you have to understand what is FTA. And the other thing is, maybe your student is most commonly dependability is when you are programming. So the programming process, what you will do, and how to find the bug. Debugging is one of the most important process. So therefore, we should consider about this. And for the second part, human error, some theories has been established. So therefore, introducing some theory and this kind of thing. This picture is very important. Slip rust mistake. Slip rust mistake is a very important keyword for error, human error. So therefore, this part. Yes. And how do you think about today's contents? You have learned something about this kind of the dependability, failure, and the human error. I don't know exactly, but first is I have to hear from you about which part you are interested in, or you want to know more, interest, or want to more, want to know more とか、or the hear others opinion とか、and so on. Anything okay that after reading and after studying something about today's content, how do you feel? I have to know firstly. So therefore, the first is Yue, can you show something your opinion about today's contents? Yes.
I'm interested in the software development process because it provides the standards to develop a software.
Okay, standard. What is the meaning of standards? Yeah. What is are you interested in about the software development? Can you explain more? Can you explain more about how this is important or this is interesting?
Because it has a set of process for us to follow.
What is your experience of your software development?
I have few development experience.
Few development experience, yes. And which kind of language you are using, and which is the development environment you are using? Can you show something about it?
Mainly Python and C++.
Python. Yes. Python and C++ is familiar for you. Nice. Definitely C++. You are developing on the Windows system? Windows PC?
Yes, Windows PC.
Windows PC. Windows Plus. Yeah. Thank you. So the next, how about the channel? What is your interest or something?
Actually, for my preference, I prefer the predictive maintenance for the question 3 because I have some background in mechanical engineering. So towards the manufacturing, especially for the CNC manufacturing, the predicting to maintenance and also the working in the machine motoring for the mechanics, they also have the experience, predictive maintenance by Siemens and other other factories, and this is actually a very interesting thing that in the real manufacture period that makes the maintenance make the maintenance mostly in the schedule.
Siemens
Right.
taking this kind of the
Predicting maintenance, so they could early find that what part of the system should be replaced, what part of the system should be fixed, and this is very interesting. That for if we could predict, we could make and it could make us manufacturing more in schedule, more on schedule.
schedule.
Right? We could uh we could plan it earlier and won't reflect it to the production.
Yes, because it is because unexpected accident is very, very damage to the manufacturing system.
Right.
So therefore, some prediction and the scheduled maintenance is very, very good for the keeping the productivity.
Right.
So therefore, it will make some cost reduction and time reduction.
A huge cost reduction.
Yes, mainly the cost reduction and time saving.
Right.
Yes. Yes, thank you. Yes. How about Hawking, Hao-chan?
Okay, okay. I'm interested in the question 5 about the, especially about the CA. I know some program based on the enhanced process automation. It is very used in nowadays. But for the CA, I think that nowadays the CA program is a little less. For example, the chatbots for the customer service is a kind of CA. But nowadays this kind of chatbots I think it's not completely developed. So I want so I want to know more about the research about the CA and want to know what will the CA can do in the future.
Presently, in many cases, some claim response or some telephone call consulting, different chatbot is already used in many cases, but it is not complete. So therefore, it may opinions or which part you are interested in.
I'm interested in the question 1.
So because I believe that the way how work is organized is very important because even the addition of a single step in each part of the process can have a very significant impact on overall efficiency. So I have some practical work experience that I can share.
Okay. So you are just maybe the most of them are usually doing some software development.
Yes.
So therefore, you also interesting about some theory or background of these kind of things. Okay? Thank you. Yes. じゃあ、ちょっとして、はい。ここでは何を言っているか。Yes, software development とか software part。ここに、definition, some definition, dependability, reliability, trustworthiness is defined in here. Okay? And also the IEC standard no definition, dependability. Dependability or repair system, non-repair system, dependability is differently the time to failure, operation time between failure, it is set. And the reliability, recoverability, maintainability, how to calculate. The availability, failure rate, it is also set. And this is robot, type of failure, something. And analysis, FTA, the FTA のイントロダクション。And the failure analysis and the failure countermeasure, failure prevention, foolproof, idiot proof, or fail safe system. ハオシャン、フールプルーフ、イディオットプルーフと、フェイラーセーフティ、フェイラーセーフ、フェイルセーフシステム。What is the difference between these two? なんか、similar word. It looks similar, but what is the difference between foolproof and fail safe?
I think that the full prop is designed for prevent people from fail, and the fail safe is that when the fail is happened, the system will not be impacted very hurtful. I think it is the difference.
Okay. Thank you. So, yes, foolproof. It is easy for anyone to use without breaking or making mistake. Yes, making mistake. So the human will make mistake. But the design so as to be impervious to human incompetence or error or mistake. So therefore, misuse-proof design. It means a misuse-proof design. So the design makes it to prevent the becoming some failure or error. Defensive design って書いてあるけど、before making some failure or mistake, the mistake prevention design, it's various operations by users, countermeasures against operating problem, and wrong operation by users. So, before making some mistake, the design makes the prevent error, miss operation as much as possible. To prevent miss operation as much as possible is a foolproof design とか idiot proof design. fail safe は、yes, we know that the mistake will usually happens. The human makes error. Design function or practice that in the event of specific type of failure inherently respond in the way that will cause minimal or no harm to other equipment or to the environment or other people. So the fail will happen. Fail will usually happens. Mistake usually happens, but the pen makes some mistake, pen makes some error, the result will not so severe. It's the fail-safe system. That is a different constellation. Yes, sir. Thank you. 次、なんかここら辺になんか how to design とか、これ four processes, planning process, development stage, and the thirdly, manufacturing stage, the sales stage. The four stages is like to design or some prevention is very, very important. これ、なんか、most important, one is designers, engineers phase is 例えば、プランニングは not so much, but the developmental design stage, the engineers will do mainly. あと、third ってなんだっけ？So, and also the manufacturing stage is also the engineers is the mainly the cope with tackling with this kind of second stage and third stage, development stage and the manufacturing stage. Yue, what is your understanding the engineer should do in the development or design stage? What we should do? What we should do in the design stage as an engineer. ここら辺に書いてあること。これに書いてあることなんですけど、it is said in here. Process design and secure operation to ensure manufacturing quality って書いてあるんです。What we should do? なんか in your words, please explain.
We should make sure what we developed is real quality and can be used many times.
Okay. Yes. Thank you. じゃあちょっと others opinion we want to hear. Chena, how do you think that when we develop some product, what we should consider or what we should do in the designing なんか product design process?
Makes the first the functions are separate and working on, and also standard. This three I think is the most important rule for the design. So making some
to make it stable.
タンパク質は取るだけじゃなく吸収しないと
Modular,
意味がない
separate, and standard.
Upon determining the
Okay, okay. Maybe next week we will discuss about the safety. And at that time, この next week の safety で we have to consider about the process of the design. ちょっと待って、ここにはないんだっけ I don't remember this. Today's part has, nothing about it.
For the better dependability, it is, I really think this three part is fairly important because of the nowadays system, if not have these three part, it means it could make the error that happens in any place, and we cannot just using some easy maintenance, easy replacement to fix it, and it also would broken in any period of manufacture.
Modular design is one way to.
Right. Modular
Yes.
design and also the standard.
Standardization ね。
Right.
スタンダードのライゼーション。ね。それは今ここでやるんだけど。
And also the system separate.
プロダクトデザインで、一応なんか重要なのは、what is the important thing is one is follow the standard. Becauseなんかany equipment is used in compatibility or others. In any systems, it can be attached when one product is failure and some other product can be replaced to it.
Right.
And also similarly, the modular design, functional dependent, each function divided the system is very useful to repairing
Sure.
case. Yes. This is one thing we have to consider. Yes, of course. But some additional thing, product design. When we do some product design, what we should consider, how do you think? Ifan, how do you think? Thank you. Ifan's idea about the product design. When we do some product design, what we should do?
The first important thing is we need to provide to tell them if it is technically feasible. So if we can achieve the expected effect as a planning. Because they may have some ideas, but it cannot be achieved on the technique side. And another important thing is as a development, we need to provide the cost, the man hour, because the cost is very important, the man hour, and if we need to purchase some equipment, and so to calculate the profit, and then is to design the product with the product manager, and develop the product, and make sure that there is no potential bug in this product.
Okay. Thank you for your opinion. Just finally, I want to hear from the Hao-Xiang's idea for some additional thing. When you do the product design, what we should do, what we should consider.
For example, if we design for any types of system, I think the database is a basic important thing. Because I think the structure of the database decide what function can we use in the future, and what function we can use in the future, and also this is not what can we extend the program in the future? It is all depended by the database. I think so. I think that the database structure is we firstly should pay attention to.
Okay, okay. Thank you for your opinion. So my answer to this kind of question, product design for manufacturers, what we should do is maybe the user analysis. User analysis is the one thing we have to do, maybe. It means who is this product's customer, and when they use it, or how to use it, and so on. So therefore, the user's profile and the usage situation of this product we have to consider. And based on this, maybe the if and saying expected effect we can find. So therefore, who is the target customer of this product, and when they use it, and which kind of situation they will use it, we have to consider. It's one thing we have to do. And maybe this database means, yes, this is said in this stage 4, says in this article じゃなくて in this material。ここになんか、セールスサービスステージで、ここのクレームインタープリテーションとか、フェイラーアナリシスとか、マーケットプロセッシング、そういうクオリティモニタリングとかっていうのも書いてあるけど、this is set in here, but maybe it means the database is this kind of なんか、users クレームとかなんかマーケットとか、this kind of thing is and so based on this information, claim, failure experience とか、なんか、クオリティモニタリングリザルトとか、クオリティとか、andなんか、マーケットサーベイとか、プロセッシングとか、マーケットプロセッシングとか、some kind of the data should be collected in the database. And based on this data, the product should be designed. It's also the one thing. And when actual designing, of course, this kind of standardization or the manufacturing なんか consideration, some cost consideration or the manufacturing complexity, it means the time, process, manufacturing process or something that we have to consider. But before actually this kind of things, maybe this kind of user analysis and the claim analysis or some failure analysis or the quality result or market survey or something, this kind of thing is important, I think. Is it okay? You have some question or some opinion about this? So therefore this っていうのは、この on this material I have said the まあセールスもそうなんだけど、 この development quality design stage、これ selective なんたらかんたら component、reliability design、service life design とか、reflecting the example of failures and the failure analysis, FTA, fault tree analysis, and durability test. This is the service life. Service life. What do you think about the service life? How do you think about the service life? What is the service life?
I think that the service life maybe means that, for example, in the industry, when we design a production, decided by the material or the structure, the production maybe have the expected using life, service life. It means that how long we can use that, and the how long we can use the production, and the how we can how we can, if we can repair that in the future. I think it is that.
Okay. Thank you. Yue, how do you think about the なんかサービスライフ、プロダクトサービスライフ？expected period って言ってる。はい。What?
I think it is how long we can provide the service.
Oh, how long it っていうのは this product provide its service か。Yes, good answer. Thank you. Because the product give some service, it means some function. So therefore, maybe the brand new product may provide some good function to you, to customers, and it makes some benefit for you. But all the products is become old とか this performance will be reduced gradually. So therefore, how much level of the performance can provide is a service life とか product life, product cycle とか cycle time とか。そう。これ、サービスとか function だよね。It means some good function can provide function can be provided how long it can provide its service function to make benefit, to make some benefit. It's the service life, product life. But because the manufacturer is want to sell some product so much to get some money. If the product is too long service life, it cannot be replaced. So therefore, if manufacturer products the brand new or new brand, the replace style product, improved product, the customer will not buy it. So therefore, the manufacturer want to buy the new product so frequently by users. So therefore, the too much durable product is not good for the manufacturers. Too much durable is not good for manufacturers. So So therefore, the product is the, なんだっけ、cost benefit, この rate is, cost benefit rate is the one important thing. But of course, this performance and the service life, service time とか、service time rate is also the another the consideration factors for the product. 例えば、1 year later, 3 years later, 5 years later, how much performance this product can provide to the users is the one important thing to consider. Of course, performance will gradually decreasing. But the common users is difficult to estimate this the performance decreasing rate. We don't know anything. So therefore, when purchasing some product, maybe some users, customers will only consider the cost benefit performance rate, benefit or performance ってことでね。performance rate. But this benefit, this performance is the initial performance. Initial. This only the initial performance we can find. So how long it can be kept is we don't know. Soこの service life, この performance gradually decreasing is sometimes depending on which material will be used for this product. For example, some metal, so iron or aluminum, if we use, it is very durable, very rigid and durable. But some plastic or carbon or plastic or sometimes vinyls, it makes initially good enough, but it is easy to become failure or become broken in some case. So therefore, the material selection is the one thing. Materials or material とか others coating って、コーってなんだっけ、コーじゃなかったっけ、coating. Yes, even in the plastic material, but the surface is coated by the vapored metal in some case. So that is very good for some keeping its performance in some case. So therefore, the coating's methodology or coating's material is also the important factor to do some good product or not. So this kind of thing is considered by manufacturers in the design process to estimate this product service life. So the service life design is also ちょっとこれっていうのはここに書いてある括弧2のこのリライアビリティデザインとかサービスライフデザインとかっていうのはdurability test っていうのは this kind of thing is depending on its design, selecting material, selecting manufacturing method, something, of course. っていうことで this is also the manufacturing quality とかさ how to keep its quality in some band, in some distribution. The small distribution quality is aligned into some small distribution is very, very difficult. But this wide distribution producting is easy to do. So therefore, the quality keeping, quality level and quality distribution is also the one important factor for the performance of the product, of course. So the manufacturing process was something, only this is process controlled something. This is what I want you to consider in this part. ってことね。で、これはロボットデザインのdependability でソフトウェアと lead to here. Some of you knows about the structured programming とか waterfall モデルとか V-shape モデルとか。じゃあちょっと we want to hear from you about ちょっとquestion 1って何ですかって言ったら question 1は何でしたかって言うと what was question 1? Software development explain the software development process including the two types approaches of waterfall, agile development. In addition, explain a common program process, generally in 5 steps. っていうのは何だったでしょうかって。はい。というので、ペンチェン、please ask each student to explain their each the answers to this question. Okay.
So Mr. Luo Yifan-san, could you please show your answer to this question?
SDLC methodology that follows the logical progression of linear and sequential phases within the project lifecycle process. Some of the key principles in waterfall include sequential structure. Typical includes phases such as requirements, design, implementation, verification, and maintenance. Strong focus on documentation, extensive details that define project requirements and implementation process. Low customer involvement requirements must be agreed upon early in the project lifecycle. Once defined, the development process is strongly focused on meeting and the agreed requirements and Agile principles. The Agile SDLC model is designed to facilitate the change and estimate waste processes. It replaces a command and control style of waterfall development with an approach that prepares for and welcomes changes. The key differentiating Agile principles include individuals and interactions over process and tools build a strong communication and collaboration mindset between team members across all functional domains, all of whom have certain roles and responsibilities in Agile. Working software instead of comprehensive documentation, tactic knowledge is more valuable than document knowledge, which is often difficult to communicate and never truly sufficiently descriptive. Communication while working together is likely to effectively communicate the necessary information between team members instead of writing this information in a large documentation resource. Customer collaboration over contract negotiation requirements change repeatedly. Especially when projects take a prolonged duration to build and deploy, and the market dynamics change unpredictably. With responding to change over following a plan, a successful project development model that has a provision to adapt can help the vendor and customer meet collective goals without exceeding project scope. And the common programming process, the five steps of programming I find in the wiki book is first, define the problem, and second, design the program, and third, code the program, and fourth, test the program, and fifth, document and maintain. So some real industry practice. So based on my experience working in the tech industry, especially in China's big tech companies, the waterfall development model is virtually non-existent. I only encountered it during the 1 week onboarding training, so where it was briefly introduced. In practice, all development follows the agile methodology. This is because the waterfall model is unrealistic. It's simply not feasible to complete all the design upfront without errors. So people are not God. It's impossible to anticipate all the issues that may arise during development. Moreover, even under agile development in big techs, every step is thoroughly documented. So documentation is considered the ultimate source of truth. So while some claim that comprehensive documentation is the strength of the waterfall model, so in reality, agile development can also achieve well-maintained and complete documentation. So our general development workflow was as follows. So first, the business manager would propose improvements based on collected business insights and draft a MRD, market requirements document. The MRD primarily focused on the market analysis and profitability. This would be followed by an MRD review meeting, so where we evaluate the expected returns, estimated costs, and determine the required man hours. So since man hours are a critical components of the overall cost. So after detailed discussion between the product managers and the business manager, and once alignment was reached, the product manager would draft a product requirements document. This would then be reviewed in a product requirements document review meeting. So where the focus shifts to specific product design details. At this stage, engineers are heavily involved to ensure technical feasibility and alignment. So next, the engineer team would prepare a technical solution document followed by a technical review meeting. So unlike the traditional waterfall model where documentation once finalized is rarely modified. So our approach allowed for continuous iteration. We would revise the technical plan based on real-time challenges and encountered during development and maintain frequent communication via meetings. So once development was complete, developers performed local self-testing, then the code would be deployed to a staging environment, which closely mirrors the production environment, but with some isolation. So after development to staging, the QA team began testing and documented the results. It's normal to encounter bugs at this stage. We will fix them quickly. And after QA sign off, we proceeded with release using a canary deployment strategy, gradually rolling out the update to a small subset of users and monitoring for issues, and then expand the rollout to full traffic. So finally, post-deployment monitoring was carried out via SRE platforms and alerting systems to ensure stability. So if no critical issues were found, the development cycle was considered successfully completed. That's all.
Sorry, no question for. for this. Next, Mr. Chen Yu-Wei-san, could you please show your answer?
Explain the software development process, including two typical approaches of waterfall development and agile development. The waterfall development. The waterfall model is a linear and sequential approach, where each phase must be completed before the next begins. The method is characterized by its structural progression through distinct phases. The early concept, Herbert D. Billington presented the first known structured approach to software development at a 1915 symposium describing phased development for the SAGE project. He later clarified that the process was task-specific, specialized, and iterative, not strictly linear. The formalization, the Winston W. Royce's 1970 paper included the first detailed diagram of what later became known as the waterfall model, though he criticized its rigidity, particularly last-stage testing as risky. He proposed 5 additional steps to mitigate risks, but only his flawed diagram gained widespread attention. The term origin, the term waterfall may have first appeared in 1976 paper by Bell and Taylor. The standardization. The U.S. Department of Defense formalized the waterfall model in DoD-STD 2167, mandating 6 sequential phases: software requirement analysis, preliminary design, detailed design, coding and unit testing, the integration and testing. The Winston W. Royce final and improved model, developed as a critical of the rigid waterfall approach, emphasized the iterative feedback loops, where testing could reveal design flaws and design challenges could expose unrealistic requirements. He also stressed expensive documentation, advised to do the job twice if possible. Additionally, Royce advocated for heavy customer involvement, a principle later echoed in agile methodologies like extreme programming. His refined model aimed to mitigate the waterfall's risks by embracing adaptability, thoroughness, and continuous stakeholder collaboration. The requirements gathering, the comprehensive documentation of all software requirements, design, the architecture and the detailed design of the system, implementation, and actual coding based on the design specifications, the testing, the systematic testing to identify and fix defects, the deployment, releasing the final product to users, maintenance, ongoing support and updates post-deployment. The agile development. The agile methodology is an iterative and flexible approach that emphasizes collaboration, customer feedback, and rapid delivery of function software. The agile emerged as a response to heavyweight documentation driven methods, drawing inspiration from practice like extreme programming, Scrum, and adaptive software development. Key principles include the delivering valuable software early and continuously, embracing changing requirements even late in the development, the frequent releases, the close collaboration between developers and stakeholders, trusting motivated teams, and promoting face-to-face communication, measured progress by working software, not documentation, to maintain sustainable development and technical excellence, the simplicity and self-organized teams to drive innovation, the regular team reflection and adaptation. As Jim Highsmith clarified, HRI is not anti-methodology, but seek balance, valuing practicality, flexibility, and human collaboration over bureaucratic rigidity. The focus remains on real-world results rather than ceremonial process. Explain the common programming process, especially in 5 steps. Regardless of the development methodology, the programming process generally follows these 5 steps. The requirement analysis, understanding and documenting what the software is supposed to do, design, planning the software architecture and user interface, implementation, write the actual code to build the software, testing, verifying that the software works as intended and fixing any bugs, maintenance, updating and improving the software post-deployment to fix issues or add new features. This step ensured a systematic approach to software development, promoting quality and efficiency throughout the software's life cycle.
So based on your own experience, are you always programming by this kind of 5 steps? How about your own experience or your own practical?
Since I have few development experience, I basically follow these 5 steps.
Oh, okay. Thank you. Next, Mr. Zhang Zhenao-san.
Okay. Here is it's here. Okay. Firstly, we talk about the actually in the real development nowadays, we usually based on the algae development that iterative and incremental approach that emphasize feasibility, customer collaboration, and rapid delivery, and individuals and interactions over process and a tool, work software over comprehensive documentation, customers collaborating over contract negotiation and responding to changeover following in implement. And also for the traditional methods that called the full rainfall waterfall development development that is linear and sequential software development. Each phase must be completed and require collecting document all software requirements, creating system architecture and detail. Just as well. We just talk about the 5 steps that for first understanding the problem, second planning the solutions, the third decoding the program, fourth testing and debugging, fifth maintenance and documentation. However, in real development, are some questions. First, even in these days, in today's work for the robotics and the manufacturer code, not just like laws, IT, pure IT for the automation, also we based on the align agile development because actually for the robot system we would easily to change the parts that we purchased on the markets. So if we couldn't we pre-designed the waterfall, we could not change the parts that supplied on the market rapidly. So we should to decouplize, to modularize the our system and makes the software to fix to accommodate the hardware. So this is the basic part for the automations. Why for the even for the automation, we also use the agile development. And the second part is fairly interesting, especially in the automations. We for one company that called the iTech that tells something called the less document. The less document means that we should make us to design better, especially to design the module better, to make the every module in our system to connect and interact in a fixed and regulated data pack. With this data pack, we won't need any extra document to for the every modules to be interacted. And this part to uh, reduce the need of document would actually improve the efficiency of development. That's all that what I know that.
Next.
Okay. Yes. Yes, thank you. Finally, the last one, student.
Last, Mr. Guo Haochen, could you please show your answer?
Okay. Firstly is the waterfall development. It is how 5 steps or can be 6 steps. Requirement analysis, system design, implementation, testing, development, and maintenance. And the character of the waterfall development is that it emphasizes through documentation and milestone reviews, and it suited to projects with well-defined requirements and low volatility. And secondly is the agile development. Agile development is that it has some key principles. Firstly, is development is organized into short iterations, typically 1 to 4 weeks, and then secondly, continuous customer collaboration and feedback. It can have the feedback of the customer, and secondly is the emphasis on working software over comprehensive documentation, and finally is the teams are cross-functional and self-organization. And the 5 common steps of programming process is that firstly is the requirement analysis. It is that identifies the functional and non-functional requirements of the program, and secondly is the system design. It is to define the system architecture, and secondly is the implementation. Also mean coding. It is that translate design into code following language-specific periodic and style guides, and the the first step is that testing and debugging. It means that perform multiple testing levels, unit integration system, and user acceptance. And finally is deployment and maintenance. It means that it must develop it means that deploy software to production environments using the orce- orchestration tools and maintain them with some teams. 以上です。
Thank you. Question one was, yes, it is the only exploring about the two methodologies, waterfall method and also the agile strategy. So therefore the only so most of the students' answer will become the same. So and also the 5 steps development also set to this kind of the software development. So therefore, we should continue to hear from your actual debugging methodology. Because maybe it is very depending on the personality or your methodology. This sheet only explain about tips for debugging. Gradually subdivide and identify debug, write an easy to understand program when debugging occurs, create an environment when you can write programs at the name and format. この variables の naming and format in advance very, very important. Global variable か local variable or call by value or call by reference to get some value is also the different way. The unify how to write branch and loop condition and the handle errors. For example, maybe you use the if-then program, when program, but the out of conditions treatment is one important thing. So therefore, this is the important thing you have to take care. Now, this is the listed up chipsets for the debugging. It looks like this. But how about your answer? We want to hear from you. So therefore, the Penchen, please ask the student.
Yes, first, Mr. Chen, could you please share your answer for this question?
Ingenuity and key points to note to make it effective and efficient. Identifying the bug. The first step in the debugging process is to identify that a bug exists. This information may come from various sources. A user may have reported unexpected behavior. A test case may have failed during routine testing, or you may have noticed something amiss while working on a new feature. Reproducing the bug. Reproducing the bug is a critical but often challenging step in debugging, requiring recreation of the exact condition that triggers the issue or difficulty, especially for intermittent bugs. It confirms the problem's existence and enables controlled analysis. Diagnosing the bug. Following the successful reproduction of the bug, the subsequent step is to diagnose it. For example, to ascertain the underlying cause. This process entails the investigation of application state at the time the bug manifests. the tracing of the code to identify the sequence of events that lead to bug, and the isolation of the specific code segment that is root cause of the bug. Fixing the bug. Following the identification of the issue, the subsequent step is to implement a solution. This process entails the modification of code to address the root cause of the bug, followed by rigorous testing to ensure the rectification of the issue and absence of any new complications. Reflecting on the bug. Following software bug fixes, conduct post-mortems to identify root causes, determine if prevention was possible, and define specific measures, like improved coding standards, enhanced testing, or better requirements review to prevent recurrence. This reflection directly improves development and testing practices during reducing future bugs. The process of debugging is frequently considered to be more of an art than a science, and the most effective strategy for rectifying a given bug may vary. Nevertheless, there are a number of common strategies that have been proven to be effective in a variety of situations. The following discussion will explore some of these factors in more detail. So first is the backward debugging. When an error occurs, start from the point of failure and trace backwards through the code execution path to identify where the incorrect state or data originated, helping isolate the root cause efficiently. Rubber duck debugging. By verbally explaining your code line by line to an inanimate object like a rubber duck, you force yourself to articulate your logic, often uncovering hidden flaws or oversights in the process. Print statement debugging. Inserting strategic print statements at key points in your code allows you to monitor variable values and program flow in real time, making it easier to detect where data corruptions or unexpected behavior occurs. Pair debugging. Collaborating with another developer provides a fresh perspective, as they may spot issue you missed, and discussing the problem aloud can lead to new insights and fast solution. Breakpoint debugging. Use breakpoint in an IDE to pause execution at specific lines as you inspect variables, step through code, and analyze program state interactively, where it is especially useful for complex loops or condition logic. Unit testing. Writing targeted tests for individual functions or modules help isolate bugs by verifying expected behavior and quickly identifying which component is failing. Divide and conquer. Breaking down large sections of code into smaller, testable segments narrows the scope of investigation, making it easier to pinpoint the exact location of a bug. Change one thing at a time, making increment changes and testing after each adjustment ensures you can clearly link modification to their effects, avoiding confusion from multiple simultaneous changes. Log analysis. Reviewing application logs provide a chronological record of events leading up to a failure, offering critical clues about system state, error, and unexpected behavior. Code review. Having peers examine your code not only catches overlooked mistakes but also encourages clearer, more maintainable code through collaborative feedback.
Yes, yes. Thank you. Thank you, UA. But as you have listed up various kind of methodology, but actually what you are doing, how, for example, how to find, identify the bug place, bug bug condition とか、how to identify actually?
From my perspective, I mainly use the breakpoint debugging.
Breakpoint debugging
Yes.
is actually doing what it is.
To break the point at specific lines to run my code step by step, line by line.
Okay. Breaking point and the checking the result or the present value or something you are checking, right?
Yeah.
Okay. That is the actual way. So of course you can, yes, you have listed that various way methodology, but the actual you are doing is you should explain more clearly, more exactly. Yes, thank you. Next.
Next, Mr. Zhang Zhenlao, could you please show?
Okay. Here, actually, for my work, it is easily to find that debug include code debug. For the first step, confirm the code complies correctly and execute without fatal errors. That's exactly. Second, for the log debug, we see the log output and make sure that where the log makes the errors. And for the log part, we could find the module that it works on well, and we go into the module and do the step-by-step and the breakpoint debug to find out where the bug being produced. And first, for the debug principles, I first mentioned that the reproduce first. As a bug it happens, it needs to be stable to be found. And second, minimize early assumptions that we should take the error types that returns exactly and use minimal examples that reduce the input to the smallest test case in order to make the test. However, in my really designs, there's another thing that I make it very important that we need when we start a system, we should firstly design about the data structures, and with the existence of the data structures, we could actually using the generalized AI to make the minimum test system, automatic test script, and also makes the generates AI to draw about the error return about functions. That if we could design the data structure before, we could make this dump and actually substitute however very important part to make the AI to replace ourselves to do this. So firstly, design the data structure, because when you design the data structure, the AI could help you to do almost every this kind of things. Thanks.
You step-by-step breaker-point system is very important, very useful. But the modularization of the software is also the important. The function, each function, or the object-oriented program or something is very, very important. Modularization. And the input-output, the control or management is also important. And the one important thing is identify the error case or error condition. So the reproducing the error case is the important, and also the test input design the okay. Okay. So for AI understanding, the data structure is important. You want to say yes. Thank you. Yes. The next student, please.
Next, Mr. 郭浩先生, would you please show your answer?
Okay. My answer of the question 2 is that I think it will have some steps to debug. And the first is to read the error message carefully. So no compiler error message usually contain a lot of useful information such as the location of the error and the type of error, which can provide guidance for us. And in addition, some developers will write the solution directly in the error message, usually for errors that occur frequently. If we read the error message carefully, maybe we can quickly solve the problem. And secondly is locate the cause of the error. When the encountering an error, confirm the line of the code where the error occurred based on the error message, and determine the functions called and the parameters used. And use tools such as I used the iPad notebook to gradually debug the code step by step, run the code and observing the intermediate states of the code to confirm the exact course of the error. And then is fixing errors. Once we have identified the location of the error and the cause of the miselement, we can begin the process of fixing the error. When fixing the error, it is important to consider the type of error and whether the same problem exists in the rest of the code. And this will benefit the overall development process. And the second is verify and test the fixed. After completing the error correction, we run the code to test whether the error has been corrected. At the same time, error prevention features such as inspections or preconditions should be added to the code to avoid unknown errors caused by incorrect input. 以上です。Read the error message carefully without one fast thing you have read all the problem. And it contains only to find some error. Okay. はい、じゃあ next finally the Ethan, please.
Yes, from my experience, so before the code is deployed, that is, or while it is still in the local deployment phase, debugging is relatively straightforward. The most common and efficient method is to use the debugger built into the IDE, set breakpoints, and steps through the code. This approach is both simple and effective. So, however, in real world work scenarios, development doesn't always stay local. The production database is always different from the local one, and there are significant differences between the local and the production environments. So, when a bug occurs in production, that's when a developer's true capabilities are tested. So at our company, the standard expectation is detect the issue within 1 minute and contain the impact within 5 minutes. So in other words, the bug must be resolved within 5 minutes. So the longer it takes to fix the issue, the more severe the incident level becomes. A bug classified as a P3 level incident is already serious enough to potentially bring down a director level employee. So especially if they lack strong backing in the company. So every year, many team leads or managers are laid off due to critical bugs caused by their team. So in our culture, a production bug is not the fault of an individual, but the shared responsibility of the entire team. So when it comes to handling bugs in the production environment, the two most critical tools. So sorry, my computer has some problem, and I cannot scroll the page. I cannot scroll the page. Yeah, yes. So the two most critical tools are logs and traces. So logs refers to the output messages written into the code, and they follow strict formatting and rules, including log labels such as error, warning, or debug. So every time we release new code, it is mandatory to include comprehensive logging. So because logs are the most valuable resource during incident debugging. So in fact, our team spends over 200,000 Chinese yuan per year on log storage and log search service alone. So the other key tool is trace. So while most developers are familiar with HTTP, so within large enterprises, internal communication between services is typically handled via a customized RPC framework. You can think of it's an enterprise-specific alternative to HTTP. So it is not built on the HTTP protocol itself. So each time a service call is made, a trace is recorded. For example, a single logistics order may pass through dozens of different teams code bases, span hundreds of servers, and run on multiple instances of the same code deployed across machine. With trace data, we can precisely identify when a request occurred, so which specific server it went through, and even see sorry, my computer has some problem. I cannot scroll the screen now.
Have you ever wondered why debugging is not taught in school? Most developers actually learn it on the job, and only a lucky few have a mentor to guide them through the process. In this video, we're going to present a systematic approach to debugging that you can use as a checklist on your debugging journey. Debugging demands discipline and is easy to get off course and wastes valuable time. We'll show you how to make sound trade-offs and use good judgment. So whether you're a beginner or an experienced developer, this video is for you. Follow along as we share our tips and tricks for effective debugging. And remember, feel free to use these in any order. There's no right or wrong way to debug. Now let's start by discussing the importance of having the right mindset when it comes to debugging challenging problems. It can mean the difference between giving up too early or ultimately solving the issue. When facing tough debugging challenges, it's important to keep in mind the following things. First, remember the computers are logical, and there's always a logical explanation for the issue at hand, even if it may seem impossible to find at the moment. Second, being stuck is only temporary, and with persistence and effort, the issue will eventually be resolved. Third, it's important to know your limits and recognize when it's time to seek help from others who may have more expertise. Finally, it's not always necessary to spend a significant amount of effort in resolving every bug. We should prioritize bugs based on their potential impact and severity. We should accept the fact that some bugs may not be worth the effort. Now let's start by covering the basics. When we receive a bug report from a customer, it's important to gather as much information about it as possible. Request a screenshot or a screen recording from the customer if possible. Additionally, collect detailed steps to reproduce the issue and gather all relevant logs, including any error messages associated with the bug. The goal is to obtain as much information as possible to help us reproduce the problem. We can isolate the environment and context where the issue occurs. We can try to recreate it on a staging server and see if we could reproduce the problem. Having a reproducible environment is half the battle. Now that we have a reproducible environment, how should we investigate the bug? Here are a few strategies to consider. First, use print statements liberally. They can help construct a timeline of what happened and determine if the event we expected to happen in the code actually lined up with the print statements. For some language ecosystems, setting up a debugger may be a viable option. For example, systems like Erlang OTP have excellent introspection capability, making the debugger an excellent first tool to reach for. Ultimately, if we can reproduce the bug, it should not be too difficult to get to the bottom of it. While it will take time and patience, following the strategies that we mentioned above should solve the issue eventually. Now, what if we can't reproduce the issue? Well, that's much tougher. It may require some luck and a lot of patience. Let's try to understand why we sometimes have so much trouble reproducing the issue. Here are a few common scenarios. Some bugs only appear under production loads, and some bugs appear under production load only in certain race conditions. There may be specific context or environment on the customer's device that triggers the bug. What can we do in these situations? Here are a few ideas. If there is a specific error, retrace the code from the line where the error occurred all the way up the call stack. Comb through all the logs for clues and build a timeline by following one failed request through the entire request lifecycle. If we're lucky, we may be able to come up with a theory as to what is happening. Next, we can add logging to the code to prove the theory and deploy it to production or ship it to the customer. Repeat this process until we gather more clues and eventually solve the issue. Keep in mind that this cycle can be lengthy and frustrating, but persistence is key. Finally, let's review some general strategies to consider when we are completely stuck. Take a break. Sometimes stepping away from the problem and coming back with a fresh mind can provide new insights. Sleep on it, get some exercise, or engage in a different activity to clear your mind. Get a rubber duck. Sometimes talking about the problem out loud can lead to a light bulb moment. For others, writing out the problem or emailing an imaginary mentor about it can help generate new ideas and perspectives. Get help. Don't hesitate to collaborate with someone else on a problem. A fresh set of eyes and a different perspective can often help to reveal new solutions. Debugging can be tough, but with the right mindset and strategies, you can overcome any challenge. Good luck.